Have you at any time reviewed whether we're genuinely alone in the universe or, on the other hand, assumed there's something different to our reality other than whatever we see? Imagine what is going on. Consider the possibility that the James Webb Telescope at last shows that we live inside a black hole. Join us as we figure out more about this world, getting the news out that will make you question all that you assumed you had some wisdom of with respect to the universe. So what precisely are black holes? They're similar to something out of a spine chiller. Sure, you could have seen them in science fiction films, but what's much more upsetting is that they're not just a fictitious concept. According to well-informed specialists, black holes in space are really huge amounts of matter packed into an inconceivably minuscule region. Imagine a star a few times more gigantic than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Researchers have been entranced by black holes for quite a while. At first, they studied objects in space so large and dense that they could trap light. The most striking ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overpowers everything else, leading to the formation of a black hole. It is not easy to identify black holes as they emit no light. However, researchers have found ways to interpret their presence by noticing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Furthermore, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, produce intense light emissions, and even affect the formation of new stars in some regions, while suppressing it in others. So how do black holes form? Picture this. Stars, once bright and shining, meet their searing end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes arise. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something many refer to as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it implodes under its own gravitational force, forming a black hole. As these massive stars collapse, something surprising happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the last defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours. At times, when two smaller black holes collide, they merge to form a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, it creates an incredible nightmare that resists understanding. Researchers have been wrestling with the size of these astronomical phenomena for a long time. Black holes come in two sizes, large and small. However, there's a bit of a misconception about them. Small is relative when it comes to black holes. Extremely large black holes, remnants of massive stars, can be as much as 10 million times the mass of the Sun. There could be upwards of 10 million to a billion of them in the Milky Way alone. That's a tremendous number of black holes that could swallow anything in their way. But wait, there's more. Very large black holes exist at the extreme end of the spectrum. They are millions, if not billions, of times greater than the Sun. These live at the centers of large galaxies, including our own Milky Way. They appear like a massive dead space, pulling everything toward them. The prestigious physicist Stephen Hawking talked about black holes throughout his life. His theories were well established, but some of his ideas proved challenging to confirm due to a lack of cutting-edge technology. Yet now there's hope on the horizon. Not too far off, a single revolutionary instrument is changing everything. It's known as the James Webb Space Telescope, JWST, and it's here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a demonstration of human ingenuity. Sure, we've launched other space telescopes before, and they've done their job well, but this rare machine is on a level that is truly extraordinary. The JWST makes the Hubble, which has served us for so long, look like a basic tool in the universe. The retail cost of this cosmic wonder is an astounding $1 billion. Yes, you heard that right, a jaw-dropping number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with massive contributions from over 300 universities. However, we shouldn't forget the risks that come with such a monumental undertaking. I understand this isn't an endeavor for the faint of heart. The JWST is venturing into an unknown world, stretching the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made several groundbreaking achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside indefinitely. During its journey, the telescope successfully deployed its enormous 5-layer sunshield and large primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after calibration and adjustments, the telescope is almost ready for full operation. One of the most exciting parts of the James Webb Space Telescope's mission was when NASA announced it had captured its first major pictures of starlight. The first image taken by the telescope was of a star called HD 8446, revealing a series of 18 scattered bright spots from the star's light collected by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446, where 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory adjusts the individual areas of the primary mirror, it will begin the process of stacking images on top of each other to create one clear view. Thanks to its sophisticated technology, the JWST will assist scientists in studying the early stages of the universe following the Big Bang. It will focus on what happened after the first stars formed, a time known as the Epoch of Reionization. This refers to when neutral hydrogen was reionized, given an electric charge once again, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are extremely challenging to detect due to how they interact with their host stars. Strong observations can now closely study these planets, allowing scientists to examine their atmospheres and investigate the conditions necessary for life. The JWST's capabilities will help researchers better predict whether specific planets might be habitable. Beyond studying planet formation, researchers focus on these worlds to understand how matter is organized on a massive scale. This, in turn, helps us understand how the universe has evolved, forming the galaxies we see today, billions of years later. One of the JWST's goals is to look back at the earliest galaxies to better understand how they evolved. Scientists are also trying to determine how we got the variety of galaxies we see today, as well as the ongoing processes that lead to the formation and merging of galaxies. #Are we alone in the universe? Ultimately, the James Webb Space Telescope will help us answer the most fundamental questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt. And guess what it has found? Compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures appear to be the goth of the universe. They're found everywhere, from distant galaxies to comets in our own solar system. Now, they're not just interesting because they could form the building blocks of life, but also because they help science track star development. When bright radiation hits these PAHs, they become energized and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument. This is often a sign that there are some hot, energetic stars nearby. But hold on for the surprising twist. Astrophysicist Ismael Garcia Bernard from Oxford University decided to examine 3 intriguing galaxies: NGC 6502, NGC 731, and the Stephan Quintet, as well as NGC 749. These galaxies are millions of light-years away in the depths of darkness. What Garcia Bernard found will send chills down your spine. In those central regions, where the black holes reign, he noticed an overflow of PAHs. Sounds interesting, right? Well, here's where it gets chilling. The radiation near these massive black holes changed the structure of the pHs, transforming them into larger, electrically neutral forms of themselves. The smaller, electrically charged PAHs disappeared into nothingness, being consumed by the very darkness. However, the larger PAHs survived, finding shelter inside thin, dense gas clouds. It's as though they found their own protective cover against the fury of the black hole's pull. Now, you might ask why this dark matter matters. Well, for space scientists who rely on PAHs to trace star formation, it's a big deal. Star-forming regions are often completely flooded with electrically charged PAHs. If those particles are lost, it means that the regions of star birth are stripped of one of the most essential indicators of stellar activity. Something similar is going on in the mysterious black hole that's swallowing them whole. In these galaxies, however, the black holes might actually help create conditions that protect those PAHs. This new discovery offers an intriguing possibility. Could massive black holes be helping in the evolution of life across the cosmos? Are black holes acting as strange sanctuaries where life might exist or be preserved, despite the extreme conditions? This raises an important question. Is there any cosmic possibility that life might have formed, not on a planet, but in the immediate vicinity of a black hole itself? As we continue to explore these distant reaches of the universe, the James Webb Space Telescope brings us one step closer to finding the answers to these questions. Could life exist beyond what we know? Could black holes be the key to understanding the very nature of life in the universe? As the James Webb Space Telescope, JWST, pushes the boundaries of space exploration, scientists are beginning to reconsider some long-held assumptions about the cosmos. The more we peer into the depths of the universe, the more we are confronted with the realization that the universe is far stranger and more complex than we ever imagined. The discoveries made by JWST are rewriting textbooks and challenging our fundamental understanding of the cosmos. One of the most intriguing aspects of JWST's mission is its ability to peer deeper into space and time than any previous telescope. Unlike its predecessor, the Hubble Space Telescope, which mostly observed visible and ultraviolet light, the JWST is designed to detect infrared radiation. This allows it to see objects that are too faint or distant to be observed in other wavelengths of light. It can peer through dust clouds and capture the faintest signals from the earliest galaxies, stars, and planets. This capability is invaluable for studying the universe's infancy. For instance, JWST can trace the formation of the first galaxies that appeared in the wake of the Big Bang, offering new insights into how these cosmic structures emerged and evolved over time. By analyzing light from these early galaxies, we may learn more about the conditions that led to the formation of stars and planets, and perhaps the emergence of life itself. Moreover, JWST's advanced instruments are providing new information about the atmospheres of exoplanets, planets that orbit stars beyond our solar system. By observing the light that passes through an exoplanet's atmosphere as it transits in front of its host star, the telescope can determine the chemical composition of the planet's atmosphere. This will allow scientists to look for signs of life, or biosignatures, such as oxygen, methane, and carbon dioxide. Such discoveries could bring us closer to answering the age-old question: are we alone in the universe? The ability to detect the presence of liquid water, a key ingredient for life as we know it, will be an essential focus of JWST's exoplanet research. Some of the most Earth-like exoplanets discovered so far reside in the so-called habitable zone of their stars, where conditions might allow liquid water to exist on their surfaces. JWST's unprecedented ability to study these distant worlds could provide the breakthrough needed to find signs of life elsewhere. In addition to its search for life, JWST is also revealing hidden secrets about the evolution of galaxies. One of the most remarkable features of galaxies is their dynamic nature. They are constantly changing. The interaction of gravitational forces between galaxies, stars, and other cosmic entities leads to the formation of new stars, the destruction of old ones, and the merging of galaxies. By observing galaxies in various stages of evolution, JWST will help scientists understand how galaxies form and grow over time. This will also shed light on the mysterious role that supermassive black holes play at the centers of galaxies. These black holes, which can be millions or even billions of times the mass of our Sun, exert enormous gravitational forces that influence the motion of stars and gas within galaxies. The relationship between galaxies and their central black holes is still poorly understood, and JWST could provide the first real clues about how these cosmic giants shape the galaxies around them. JWST's ability to capture high-resolution images of distant galaxies also opens up new avenues for studying dark matter and dark energy. While these two phenomena make up most of the universe's mass and energy, they remain largely invisible to us because they do not emit, reflect, or interact with light in any detectable way. Dark matter is thought to be responsible for the gravitational effects we observe in galaxies, while dark energy is believed to be driving the accelerated expansion of the universe. By observing the distribution of galaxies and the way light bends around massive cosmic objects, a phenomenon known as gravitational lensing, JWST may provide clues about the nature of dark matter and dark energy. Understanding these elusive substances could lead to a revolutionary shift in our understanding of the universe's fundamental forces. In many ways, JWST is already changing the way we think about the universe and our place in it. As it continues to deliver groundbreaking results, it could eventually lead to answers to some of the biggest questions in science, from the nature of black holes to the possibility of life elsewhere in the universe. It is clear that we are entering a new era of discovery, one in which the answers to these questions may be just beyond the horizon, waiting to be uncovered by this extraordinary instrument. The cosmic mysteries that have fascinated humanity for millennia are now within our grasp, and the possibilities for what we may learn are truly limitless.